Hello, my name is Brian. My capstone's essential question is what skills can I develop slash improve to pursue a future in electrical engineering? I chose this essential question because as a kid, I've been interested in building electronics. Well, more like repairing old electronics like the NES and a PS2. I hope to make a career out of this because I really enjoyed fixing and creating different types of electronics, and I thought it would give me a sense of enjoyment and achievement that I would want in a career. Before this project started, I had some basic experience in building electronics. It's not a lot, but I knew like basic soldering and how to read some circuit boards just to like figure out what's going where. But it's nothing too intense and it's very minimal. I explored my essential question by attempting to create an arcade machine. The goals I've set for myself were to learn skills that would help me during university and my career. These skills that I've thought of were CAD, machine learning, programming, and basic computer literacy. The steps I've taken to help me achieve this were finding a mentor, setting deadlines, and enjoying the process. I didn't want to, the reason why I picked engineering, electrical engineering, is because I really enjoyed making electronics. So I didn't want to take the enjoyment out of it because I feel like I had lose my passion, and that would in turn result in a slower and me gaining less skills related to this career. I chose Mr. Louis as my mentor because he was reliable and knew the skills I wanted to learn. Mr. Louis teaches robotics, electronics, and engineering, and I've taken his class since grade 9. So for 4 years, Mr. Louis has helped nurture my interest in electronics and engineering, causing me to see him as a mentor even before this project started. During this project, I learned many skills. Although I've had a lot of experience tinkering with electronics, I've never really had the chance to make electronics from scratch. So the experience was distinctly different for me. When I was trying to create my arcade's shell, like the outside part of it, there were three core machines I learned for this. Uh, there was the table saw, the radial arm saw, and the miter saw. These were all more working skills, which I've never really done before, so they were very different. But I learned them pretty quickly. The table saw was made for longer, precise cuts. The radial arm saw was made for shorter, symmetrical cuts, and the miter saw was to cut pieces at an angle. And I used a combination of the three of them to create my arcade machine. And I think that the opportunity to use these tools I probably wouldn't have used otherwise is very valuable. Through software called Lightburn, I was experimenting with 3D laser engraving. The machine Mr. Louis has was an older model, so it wouldn't let me cut complex designs. However, the error is about zero point 0.4 millimeters after testing it, so the simple vector images were possible. So how laser engraving works is that a CO2 laser emits a high heat at the wood, so it burns away small layers of wood at a time, and it leaves a distinct mark on the piece. And then if you use a computer-controlled route, a CNC machine is usually what people call them, or it's the shortened term. You design a path, and you design like how you program like the depth levels of where you want to be, how far you want to move, and you get your image. So you could import like a basic image, and you would get get your your engraving. That's very simple. But if you want a more complex design, the laser needs to be calibrated for that. So what you need to do first is you need an image that reflects your layers. So uh, a depth map is what you would use for this. It basically renders your image into multiple layers. So if I take this box, for example, if I hold it like this, there's a layer here. It's at a different depth than here. So what it does is it scans your image and it basically pulls each of these different height elevations into uh, a readable form that a computer can use. It's very comparable to a CT or an MRI scan that doctors use, where it scans each layer of the body and converts it into imaging data that the computer can register. Uh, for doing this, you'd want to use a program like CAD because a CAD program because they're more suitable for this. They're meant for 3D images, unlike Lightburn, where you can of course do it, but the layering is very hard and you wouldn't get a very clean design. So this is the actual Raspberry Pi itself. It's pretty compact. Like if I compare this to my wallet, it's equal size, if not smaller. Uh, though really the important parts about this are the CPU and the processor here. It has a micro SD card for storage right here. It has a bunch of ports. So these are HDMI ports for controller connections and other types of like if you want to have a very long USB line connecting to something, you can do that. This is for Wi-Fi, and this chip is also for Wi-Fi. So they let you do wireless and wired Wi-Fi, which has its purposes. This is a really important one. This is your display module. So this will allow you to connect to monitors. And all of these pins right here, there are 40 of them in total, and each pin corresponds to a different thing and would allow you to connect different electronics to it. So if I wanted to connect an LED, then there's a certain pin here. And of course you can code the pins to your needs, but it's really cool that there are 40 of them and that they have all their own needs. And then if you need it for a specific purpose besides that, then you could recode it. And I think that the freedom of this is really nice. Okay, so I'm gonna show you how the Pi actually runs. So I press source, it will switch to the Pi. And right now it's just loading up. So this is like what it looks like when you're booting. Of course you have to download some software first. So what I had to download was RetroPie. There are other softwares that you can use, but RetroPie was one of the two mainstream ones that most people use for this type of emulation. And there's no real drawbacks to using RetroPie or the other ones that were there. They all serve like the same purpose. But to first, you'd first want to configure your Pi 3 or whichever Pi you have. So you go to ras config, and then in this, you would set a host name. A host name would allow you to find your Pi through networking, through your internet. So you select host name right here, which is S4. I will bring you closer. You can set a password as well, but it's not super relevant because most people aren't going to be uh, most people aren't going to be trying to hack into your Pi. Then you have to go into Wi-Fi, and I've already connected to Wi-Fi. But if you haven't connected to the Wi-Fi yet, then you would go to connect your Wi-Fi, and you would go into here, and then you just find the Wi-Fi that you're on, and then you enter your Wi-Fi password and connect to Wi-Fi. After you connect to Wi-Fi, you'd want to go to my network. Okay, so to configure your Pi, you want to search up your Pi in your networks. So to do that, you first need to have your Pi and your computer or laptop connected to the same Wi-Fi, which was already done for me. So for me, all I need to do is search up my emulator, my Pi 3, and I've named it RetroPie. BIOS configs and splash screens are quality of life things, and they make your Pi run, so you don't need to worry about that. But your ROMs are your games, and you want to go into this. All these folders are different types of systems. So depending on which system you want to upload to, you click that. So these are all SNES games. So I want to move these ones over to the SNES section. And when I load my Pi 3, they'll load under SNES, and I can open that and I can run these games. So after you've loaded your games into your system, you would select your
your console and you select your game. So for the purpose of this, I'm just gonna select Tetris Attack. It's very simple. You press your A button twice to get in. If you wanna, sometimes you'll have to configure it, but once you get to that screen, there's just a red button that says launch, and that's all you need to do. And then otherwise, you're free to play whatever you want to play. This is a preview of the arcade machine. I made all the holes using a drill press, so the sticks and the buttons would fit in perfectly. And then I also made a hole in the side for wires to come in and out. The machine itself is held together with flathead screws, and I also bolted inside the pie and any other loose wires so it wouldn't shake in transport. This experience has deepened my self-awareness and my understanding of engineers. I used to believe that being an engineer was more about designing stuff, and you wouldn't really have to worry about the creation of your inventions. And I was like, very, it's very hard work. It's very hard work creating your inventions, and it's very like through creating this project, I really understood that it's not easy. I've stumbled at a lot of points. I had a lot of failure. I definitely had to ask my mentor a lot of questions on how to solve things. And I think that's okay. I think that was good for me. I definitely learned a lot from just failing. But in general, I think that my awareness for the amount of effort some that goes into like something like a phone or like a mouse, something really simple, even like a USB drive, my appreciation has really gone up. As I said earlier, there were a lot of obstacles, like the light burn was and laser engraving was failing, but the just like overcoming them through persistence was it wasn't the smartest choice. I'll admit that, but it was a choice that I'd probably pick again. Uh, like the addressing them with trial and error isn't always the best way, but from an engineer standpoint, I think that you should be trying stuff and seeing what goes wrong, and then you should be adjusting to them. Like in my past, in my past mistakes with Lightburn, I wasn't just continuously trying the same thing, hoping for a different result. I was adjusting the heat, I was adjusting the speed. There was a lot of adjustments, even small, but still there's small adjustments in the goal of creating something that I'd be proud of. I think a key to my success is definitely my persistence, but I also want to say that my my mentor, Mr. Louis, definitely helped me. There were a lot of programs that I used, and he had great recommendations for which ones I should be using. He helped me pick out my Lightburn. He helped me pick out CADs. Like he explained to me why I should be using this and like why it's better than the other ones and which ones are better for this and that. And he just had a lot of experience where it would like my success was I was using the right tools. So my persistence at it gave me success. Like I wasn't using the wrong tools. So even if I kept trying, it wouldn't give me any results. And I think that was very helpful. My overall capstone was very slow because of the failures that I had, but I think that it was good that I was slow. I think moving slowly allowed me to learn and reflect on it because I w midway. It wasn't like I just reflected at the end. Like I was reflecting it through a lot of the steps because I had so much failure. Like my laser engraving experience was terrible. I I tried to model. I tried to do layers and model some more complex designs. I tried to burn. I tried to have a lot of margin of error, and it just wasn't working. Like there were a lot of points where I probably should have given up. Like if I think back about it, I probably should have realized earlier that it wasn't possible. But I think that my persistence it slowed down the progress I would have had if I just let go of certain aspects. And I think failing is fine. I think it was great, but it really helped build my persistence and endurance against difficult and challenging tasks. Like I remember there was like a night where I just watched a whole ton of videos. I asked a bunch of computer science geeks that I know, and like they're all like, "You should try this, you should try that." I was just writing everything down that I should be trying, and none of it worked. But I think that the I gained a lot of persistence just trying to go through it. So the overall process, even though slow, was achieving and a good teaching experience. When I reflect on my growth, there was a lot of mindset changes. My first initial thought of engineers has completely changed. My first thought of engineers were very naive. I definitely thought that they don't. It's hard to get into. Like I thought it was really hard to get into, but I thought like what you do as an engineer is pretty mellow and easy. Once I tried to like make something and try to make this arcade machine, it's very difficult. Like the theoretical part of it is different than the experimental part. Like in reality, it's things go wrong. You got to account for stuff going badly. Even if you're not fooling around, even if you're doing everything that you should be, stuff happens. Like, and that's just a part of being an engineer. Um, I think that was uh really really meaningful, something that's really important to learn. I also learned a lot about my own my own strengths. I definitely think that my ability to endure and persevere has grown. I definitely say before this project, I definitely wouldn't say that was a strength of mine, but doing going through what I did with all like my obstacles and difficulties, I definitely didn't give up. I definitely challenged them when even my mentor told me that it's probably a machine error, and no matter how much you try to optimize, it's not gonna be able to work. Eventually, of course, I have to realize the reality of the situation. But I think that going into engineering, like if I gave up so soon, I don't think it would have been a good fit for me. I think that being able to improve my perseverance, it was definitely meaningful. And uh, as a person, I'm really, really happy about where I am now. I think that I've grown a lot since the start of this project, and I hope that these attributes carry on with me for the rest of my life. Now that the capstone project is ending, I think that I've learned a lot about myself and how engineers think. I think that I've definitely taken a step towards becoming an engineer. I've learned a lot of skills that will be relevant towards my career and my post-secondary future towards that, such as CAD, machine learning, programming, and some other computer knowledge. And I think that this project has allowed me to take steps forward towards my own growth. I think that I learned a lot about my strengths and that I should be trying to face challenges and that I should be trying to put myself in more discomfort. And I think that perfectly sums up what I've learned from this, that my strengths are maybe they haven't been fully drawn out yet. Maybe I also have other strengths. Maybe perseverance isn't even my best strength, but I'm not gonna find out unless I'm challenged. And I think that's the main takeaway that I should be always trying to grow. This is the end of my presentation. I'd like to thank all my peers and my mentor for all the support I've been given. Thank you.